Hey Opties! Today we're talking about function families. We've got 6 different types of functions to look at today, but at first we need to review what a function even is. So a function is defined as a relation, so a relationship between two things, where each element of the domain, which would be your inputs or your x values, is assigned or has only one element of the range, which would be called your output or your y values. So when I input, say 5, I should not get numbers 10 and 12. I should only get, say, number 10. Basically, you can't be in 2 places at once, right? So at this time, I'm only at this place. You cannot be in 2 places at once. That's what makes a function. So let's look at some examples and non-examples in our pictures here. For these examples, the first one's a graph. Yeah, it looks all crazy and zigzaggy, but is there any point where if you drag a line across these x values, you're gonna find 2 y values for any x value? No, it'll pass the vertical line test if you remember using that in 8th grade in Algebra 1. Next is a mapping. Let's look at the input A. It only goes an arrow to D. It only goes to one thing, which is D. That passes so far. B goes to D. Well, A and B both go to D, but as long as there's not an arrow like this coming from one of your input values, you're good to go in a mapping. And C goes to one thing, E. Next, we have a table. Do we have any x's repeating? No. We don't have more than one output for an input, so we're good there. Now let's see how non-examples will show us what a non-function looks like. For our graph here, we've basically taken that zigzag and tilted it, right? We've rotated it 90 degrees. And if you draw this line here, you can see my cursor here, I'm hitting 1, 2, 3. If you go over here, you're hitting like 4 y values for this particular x value. That means you're in 4 places at once? No, that's not right. That's not a function. Look at this B. It goes to 2 things. Input B, you get D and E. Not a function. Look at this table. For an input of 2, you get 4. For an input of 2, you get 6. That's 2 outputs for the input of 2. Not a function. So that's just a quick review of functions. What we're really concerned about is looking at the types of functions. So let's go ahead and take a look at that. Our first function family is linear. 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 I'm supposed to call it linear, but I say linear because it's a word line. Linear functions are one straight line. That's their shape. There are 3 linear equations here: slope-intercept, point-slope, and standard form. And the things that go into making those equations are here right below it. We'll get into slope-intercept and point-slope pretty soon, and later on in the year we'll really get into standard form more. Looking at the graphs, all of them are one straight line. This first one, your arrow's starting down, then goes up, so it's increasing. It's got a positive slope. The second graph, it's decreasing. Your arrow starts up, then down, so it has a negative slope. Constant. Your line is flat, right? That's a slope of 0. Our next function family is absolute value. Now this looks like a big V. This thing right here is called your vertex. And the reason it's such a symmetrical V is because of how absolute values work. If you remember from previous classes, absolute value means distance from 0. So if I substitute 2 in for x, well, what's the distance 2 from 0? Well, that's just a distance of 2. But I could also say, if I'm looking at a number line, and I plot -2, how far is -2 away from 0? Well, that's also 2. So it makes negative numbers positive if you want to think about it that way. So if you look at this graph, 2 goes to +2, -2 goes to +2. And if you make this whole entire absolute value of x negative, where it reads y equals negative absolute value of x, you'll get this V flipped upside down. Okay, so like an upside down peace sign. Our next function family is quadratic. The equation is y equals x squared as the parent function. Now when I say parent function, that is the simplest way of representing a function family. So it's one of the parents, and any numbers you add to that type of equation, to that function family, would be called a transformation, which are basically the little children of the parent function. We'll get more into that later. But the way you can identify a quadratic from an equation is look to see if its highest exponent is a 2. So it's squared, x squared. The shape looks like a U or an N, or you can also think about it as a valley or a hill. And the shape is called a parabola. If it's positive, it's a valley or a U. If it's negative, it's a hill or an N. Our next function family is square root. So you've got a root and you don't have any number written for the root, but if it's invisible, it's understood to be a 2. So it's called a square root, just like if you're squaring something that's an exponent of 2, like this quadratic. Square root would have a 2 as the root. It looks like an angry eyebrow if you ask me. I've also heard it be called like an arrow shooting off into the distance. You're sitting in and you're shooting your arrow and it goes pew! So I also think it looks like an angry eyebrow. If your square root graph is positive, it looks like you're really shooting that arrow or you've got your angry eyebrow. If it's negative, you flipped this and now it looks something like this. What a square root really is half of a sideways parabola. So it's like if you took this quadratic, chopped it in half on its symmetry line, like take this and only take this piece, and then you tilt it, put it on its side. Our next function family is cubic. I like to call these Superman. It looks like Superman is flying. If you really squint hard and like really have an imagination, it looks like it could be Superman. The way to know what a cubic is from an equation is to look for the exponent of 3. The highest exponent is a 3. So looking at the graph of a cubic, if it's positive, the arrow starts down, then up. So it's flying up to the right. And that's what I mean by down, up. That's called end behavior, where the arrows point if you're reading it from left to right, just like you're reading a book. If it's negative, the arrows go up, then down. So up, then down. It's like Superman decided to fly the other way. Our next function family is cubed root. So taking a look at this, it's very similar to our square root, but instead of having an invisible 2 as the root, we have a visible 3. So look for that root of 3, the little 3 just hiding in that little root spot. This looks like a sideways Superman. All right, that's it for function families. That's just an intro, a general overview of all the functions we're going to talk about in this unit. See you next time.